Hello, my name is David Malcolm of Mississippi State Extension, and I'm here today to talk about the work we've done in Biloxi's Back Bay on submerged aquatic vegetation, or SAV, and its mapping. Biloxi's Back Bay is a low salinity estuary system that's home to diverse communities of plants and wildlife that live along its salinity gradient, as well as a vibrant community of coastal landowners. Over time, those coastal landowners have increasingly sought methods to protect their shoreline from erosion, and likely will continue to do so. Historically, the prevalent shoreline erosion control solution was to install a bulkhead. However, we now know of the ecological consequences of bulkheads and their high lifetime costs. Today, living shorelines are an alternative to bulkheads that offer erosion control, typically at a lower cost than bulkheads, while also providing the natural benefits that we know and enjoy. Originally, we set out to map Back Bay to understand the distribution of bulkheads and natural shorelines throughout the estuary. To accomplish this, we utilized drone technology. We flew a drone to take aerial photography throughout Back Bay, then used ArcMap software to piece those photos together into this map, only excluding the airspace of Keesler Air Force Base. Once we had the map, we set about delineating bulkhead shorelines, represented here in yellow, from those which were kept as natural shorelines, represented in light green. While we were doing this, we noticed that we could also see SAV patches in our photography, outlined in blue, and that we tended to see the patches in conjunction with natural shorelines much more than we did with bulkheads. We decided to investigate this pattern by adding a 10-meter buffer around the outlines of the SAV patches. Using ArcMap's internal analysis tools, we determined the length of both natural shorelines and bulkhead shorelines that intersected this buffer. This shows us the length of each shoreline that's associated with an SAV patch within 10 meters, and which type of shoreline is most associated with SAV. In doing this, we found that nearly half of the natural shorelines supported an SAV patch, while less than a quarter of bulkheaded shorelines did. Additionally, in the range of Back Bay salinity gradient that was less hospitable to the dominant species of SAV patches were only found associated with natural shorelines, with none around bulkheads. From this, we can demonstrate an association between SAV and natural shorelines. This association could be due to the negative impacts of bulkheads through increased wave energy, sediment depletion, boat traffic, and dredging, or it could be associated with the positive impacts of natural shorelines through improved sediment and nutrient supply. Likely it's some combination of the two, but more research is necessary to understand the impact of bulkheads, the role of SAV in this community, and the habitat consequences of losing the SAV. Until then, we can show that natural shorelines are more closely associated with SAV in Back Bay, and that there's likely more habitat value in promoting shoreline conservation than we currently recognize.